Yesterday we previewed the text, what is a subduction zone, and collected some preliminary noticings based on our first reading. Today we're going to reread that article, but instead of previewing, our focus for our reading today will be on visualizing. Visualizing or creating mental pictures as you read helps you make personal connections to a text and apply those text concepts. This article describes real-world events through words, and supplementing these words with a visual image can help us increase our understanding. This is why many articles are accompanied by images, as you see here. Yesterday I read the first section of this article to you, and today I'm going to read the tsunamis section to you. Please follow along as I read. When subduction zone earthquakes hit, the Earth's crust flexes and snaps like a freed spring. This can cause a tsunami, a giant sea wave, by suddenly moving the seafloor. However, not all subduction zone earthquakes will cause tsunamis. Also, some earthquakes trigger tsunamis via underwater landslides instead of seafloor motion. Whatever their cause, the tsunami threat from subduction zones is monitored by government agencies in countries around the Pacific Ocean. Tsunamis may strike in minutes for coastal areas near an earthquake, or hours later after the waves travel across the sea. One area of the text that I could make a visualization with easily is that first sentence. When the subduction zone earthquakes hit, the Earth's crust flexes and snaps like a freed spring. This made me visualize a coiled spring launching itself up to release pressure. That I could easily visualize, and it gave me a mental image of a section of Earth similarly launching itself upward. Then I went to Google Images to try to locate a graphic representation of this section of Earth springing up. My successful search term ended up being tsunami cause. First I did just try Googling tsunami, but that just returned photos of large waves. So I changed it to tsunami cause, and that helped me find these results. I like this image here. Although there isn't a spring on it, I like how the arrows show how the plates were pushing against each other, building up tension like a coiled spring, and when that tension became too much, one was suddenly shoved upward, creating a large upward wave. I'm going to save this image to my computer because I will need it for our visualization activity. You have 2 tasks today. First, reread the entire article independently, what is a subduction zone, this time with the focus of visualizing the written text as you read it. When you and your partner are both done reading, discuss what images were conjured up in your mind as you read. What did you visualize? Then I would like you to go to Google Images and find an image that matches one of your visualizations and save it to your computer. Task number 2 is to share your image in Schoology. So if you go to the next page past our mini lesson video for today, you will find our area where we will share our visualizations. Use the Add Media button on this page to attach your file to our album. Choose Attach Files, browse to the location on your computer where you saved the file, and choose Open. After you click the blue Add Media button, you'll see your image appear. I want you to click on it, and in the comments area, copy and paste the text from the article that matches this visualization and give a brief explanation. Make sure to click Post. Please note that your visualized image does not need to be an actual scientific diagram like this. I could have just as easily uploaded a picture of a coiled spring if I wanted to. This image just matched my visualization better and helped me understand that part of the article better. If you have questions, please raise your hand. If not, go ahead and continue with your reading of what is a subduction zone, this time with the focus of visualizing as you read.